Thank you for the chairman's kind introduction. Good afternoon, ladies and gentlemen. Ni hao. I'm Makoto Kayashima with Taisei Corporation from Japan. I'll start my presentation. My title is A New Demolition System for High-Rise Buildings. In Japan, because of progress of technology, legal revision, and economical reason, some tall buildings were demolished, and the new higher buildings have come out. And it is expected that the demand of steel reproduction continues to increase. This is a traditional demolition method of the building in Japan. There is few cases of blasting building using dynamite in Japan. The building outside is covered with the temporary scaffoldings and soundproof panels. But top part of the building is uncovered like this. Some heavy machineries on the top floor demolish the floor, and crawler crane placed next to the building carries out disassembled materials. We think that this method is excellent in cost and the work period concerning under 80 meters height of buildings. If the building is over 100 meters high, the strength of temporary scaffoldings, prevention of scattering of dust particles in wide areas, construction noise reduction, the risk of falling objects will become important matters. Then, new demolition methods for high-rise buildings were developed. The development concepts are safety, environment, and work period. It has features of closing space on the building top part, and the entire demolition work is completed inside the building. The closing space can be done automatically using a jack system, so safety and continuous work are realized. By closing the top part, sense of security is obtained in the neighborhood. Without the influence of a strong wind of the building top, the work period can be shortened. When it sees from outside, the building seems to be shrunk step by step like this. The new demolition method was named TECOREP system. Initials were taken from Taisei ECOlogical REProduction system. Please do not care, although some are not an initial correctly. The TECOREP system utilizes the top floor structure of the existing building, and closing space is built by suspended scaffoldings of outer perimeter of the building. The floor closing space is supported by the temporary columns with automatic jack down mechanism. The weight is transmitted to the structural frame of the existing building. The floor closing space is supported by the temporary column. The weight is transmitted to the structural frame of the existing building via the beam A or the beam B. The lower half of temporary column penetrates through the preset slab opening to resist to an earthquake and a typhoon. These guide frames on each floor carries out the horizontal restraint of a temporary column. Some cranes are arranged inside to move disassembled materials horizontally and to move them to the ground level vertically. This is an office building in Tokyo which adopted the TECOREP system last year. This is the second demolition project in Japan, over 100 meters building. It is a steel structure having 24 stories and 105 meters high. The building has an area of 1,750 square meters. Long side is 70 meters, short side is 25 meters. The exterior walls are built with natural stone-clad curtain walls. It was a young, high-rise building of the 1992 completion. It was 90 years old at the time of 2011. After disassembling this building, 200 meters skyscraper is scheduled to be built newly. The site was narrow, and there was no space which installed the crawler crane for demolition. Moreover, there was also no space which places the disassembled materials temporarily. New demolition method also suit such severe condition. These are section views of execution plan. The 12 temporary columns are set up. 6 temporary columns have been arranged to these each line is by 12-meter span. 6 heavy industrial machines are arranged inside the closed space, and floor concrete, steel girders, outer walls, and steel columns are disassembled in order. In order to advance demolition efficiently, it is necessary to move the disassembled materials. 4 ceiling traveling cranes, 3 vertical transport cranes called TELFA are set up. The concrete slab openings are made in the floor of each story, and TELFA carry disassembled materials downward from closing space to the ground level. Dropping of small concrete pieces are also performed using the old elevator shafts. On the ground level, inside the building, disassembled materials are put on a truck and taken out. This photo is in the situation of lifting one unit of a suspended scaffolding. The side of this building is surrounded in all the 24 units. This special scaffold was developed for the new method. They are suspended from the 66 cantilever beams on the building top. The height of scaffoldings is 20 meters. Light in the workspace was taken by partially using the see-through panels. It took about 4 months to construct closing space of new system. This is a construction procedure of closing space. Although not shown in this figure, first, 13 tons crane is installed on the roof for assembling 60 tons crane. Next, 150 tons crane is installed using the 60 tons crane. Using the temporary 150 tons crane on the roof, suspended scaffoldings, temporary columns, ceiling cranes, and TELFAs are lifted and set, and heavy machineries are also lifted by the crane. A temporary column was divided into 5 parts to assemble in the closing space, and they were connected at the 23rd floor level. After lifting and installing the scaffold of 24 units, each was connected with the next scaffold unit. After assembling required temporary materials, the cranes for assemblies were disassembled and taken down in order. Before completing, in other words, before cutting the existing columns, load test of jack was done. The strength of the existing frame and temporary devices are checked by the test. The existing columns were cut and the weight load of the system was shifted to the temporary columns. It was 1,300 tons in weight. After setup, demolishing one floor and a jack down repeats to the end. Steps of the building become low are shown in simple animation. This figure is a scheme for the temporary column, beam A, beam B, and guide frame. Beam A and jack can move up and down through the temporary column. For 2 hours during the jack down, beam A and hydraulic jack support the weight of the TECOREP system. And for closing space, go down 4 meters by automatically jack system. While the dismantling work is proceeding, beam A and jack are retracted into the upper part of the temporary column to avoid becoming an obstacle. The beam B can pass the opening of underfloor by folding up both ends. Before end of jack down, the beam B extend both ends and get on the next underfloor. During each floor demolition work, about 4 or 5 days, beam B located 2 floors under of demolition floor supports the weight of the TECOREP system. Guide frames are guide for temporary columns smoothly move. And guide frames are relocated sequentially to the lower level floor. This photo is work proceeding situation from outside. From left to right, July, September, November, December. You can see the building was becoming lower gradually. The pace of demolition went on 5 days per one floor. We experienced the big typhoon in September 21st last year, and safety has been confirmed satisfactorily. In December, the closing space itself was demolished without any delay. After finishing one floor demolition, closing space of TECOREP system go down to the next underfloor by automatically jack down. Left photo is before jack down, and right side photo is after jack down. If the position of this girder is compared, it turns out that it fell by 4 meters. It took about 2 hours to lower the system of one floor height 4 meters. 4-meter jack down per floor was executed every week and repeated 21 times for 5 months. Although jack down work was done safely, no problem, we had many visitors each time. It was hard work to treat them. This is a view of full closed demolition space. This photo is a ceiling of the demolition space, which used the roof of the existing building effectively. Bright working space was made by some top lights. These are steel structure, steel girders of existing building. These are the steel columns of existing building. There were 39 columns in this building and all were cut by fire. This is a telfer, and these are the ceiling cranes and rails. The ceiling cranes are two-step slide type, so they can reach all range of the work area. The lower beam can slide in the direction of outside to the position of wall. The worker did not be hit by sun rays directly in this closing space. It helped to the workers. And for the workers, 10 sets of air fans were used and mechanical ventilation was performed 5 times in 1 hour. This is a photo of floor concrete slab cut by a concrete cutter. Then, this slab was carried downward to the ground level using telfer. This slab is about 4 tons in weight. The capability of a telfer is 8 tons. Floor concrete slab was also taken the method of breaking with heavy machinery and put into a big steel box called base cell and carried downward to the ground level using telfer. This new method is effective to reduce the outside noise level. According to the simulation, it can be expected 20 decibel reduction effect as compared with traditional method top uncovered. The reduction effect has been checked by the measuring both inside and outside the roof. This photo is a control room installed on the center of the roof. Temperature, humidity, wind speed, the load of each jack, vertical displacement, strain of temporary columns, response of acceleration were measured to confirm safety. Left screens are the monitors that displays various measurement values. Right side machine is a control board of a jack system. It was operated controlling relative displacement of 12 jacks less than 10 millimeters. One telfer of 3 was built up with regenerative brake system. This system is fit for demolition work of high-rise buildings since the system can generate more by taking down more heavy weight from a higher place. A graph shows the relation between weight to take down and the production of electricity. This is a case of 95 meters in height. Although the telfer has ability of 8 tons, In this office building case, it was used generally at around 4 tons. So 3,000 kilojoule of produced electric power was measured. On the other hand, 1,000 kilojoule is needed to raise an empty hook. Totally, 2,000 kilojoule of electric power can save by one round. This time, it used effectively to the electric power of lighting at night and air fans. This photo is a partial study model of the second project. This building is a steel structure having 40 stories and 139 meters high. It will be the tallest building demolished in Japan. The feature is it has a complicated shape like this. Many corners. It has the upside-down V character shape of plan view. These parts are suspended scaffoldings of TECOREP system. The truss frame is planned using the top floor of an existing building. The diagonal bracing are added to the steel frame. The temporary column and suspended scaffolding of first project are reused for low cost. Now in September, closing space on the top is under construction. It will start to fast jack down in November, and demolition will be end in next June. In fact, this is a famous hotel in Tokyo, so now you can see many construction movies and photos of second TECOREP system by YouTube or bloggers pages. You can search them easily. Concerning future demand, a left graph shows there are many cases of demolishing high-rise buildings from 30 to 40 years old in the world. And it turns out from a right graph, the high-rise buildings over 30 years old will increase near future even in Japan. These graphs were created from the data of skyscraper.com. By improving the new system, I think it would be contribution to the cities of reproduction. Thank you. 谢谢。